Hey guys, and welcome to another video in the course about Python GUI development. As you all know, again, by now, my name is Bo Milanovic, and in the last video we defined a skeletal structure of our application. We defined some of the methods that we are going to use. We have set up the UI, we have also created the files that we needed, and we're later going to connect the signals that are emitted in our application, such as the action triggered or button clicked, in this case, to these slots that we have defined in the previous video. We're not going to do that right now. Right now, we're going to define a somewhat sturdier skeleton, so to speak. Even though our application is not really going to be useful in the world, not really going to do anything specific, we still want to create it so that it looks professional and that it is professional, and we're going to use a lot of cool stuff that the Qt offers to communicate with the operating system. And like I said, it's still going to be somewhat a skeletal structure, but it's something that you should apply to all your future applications if you want them to be, serious, real world distributable applications. Everything that I'm about to do, your application could potentially work without it, but there are some hoops. Okay, so what's the first thing I should do? Let me actually put a statement or two before all these import statements right here. The first one is I'll create a variable called the app name. I'll create it by doing the to underscore thing, and our application's name is PyDataMan. And another thing I will do is have this module variable as well, and I'll call this main. Now, like I said, this is not something you must do, but it is going to be useful later on in the course or in designing this application, and you'll see why. Okay, so that was fairly simple, nothing new there. I should warn you, by the way, that this video particularly may seem a bit more overwhelming than usual, since we're going to introduce ourselves to a lot of new stuff. But bear with me and everything should be clear to you, and if it's not, there is that box on the right where you can ask questions, and I'll make sure to answer them as fast as I can. Okay, so what's the second thing we should do? We need to figure out what folder we want to write our files into. Now, why do we need to write files? For two main reasons for now that I can think of. The first reason is that we're going to need to save our settings somewhere. So, when a user opens a preferences dialog, he or she wants those settings to be saved even after he shuts down the application and starts it again. He or she wants those settings to be preserved, obviously. And we also need to save our database to a file. I'll talk more about SQLite in this video in particular, but for now, let me just say that SQLite saves to a file, saves its database to a file as opposed to some other database engines. Here's the thing, however, we're going to package our application as an executable and as an installer, and the installer is by default going to install the application to program files. That's all fine and well, but the program files directory is not writable directly even from within the application itself. So even if you start the application from the program files, which is what your users will be doing, your application will not be able to, by default, write to that program files directory. It is able to write to existing files, and it is able to read from them, but it cannot write and create new files. And that's something what we need to do. We need to create a database file, and we need to create a settings file later on. Now, we could go around this issue in two ways. The first one, or actually in three ways. The first one, and the least preferred one, is to instruct your user somehow to run your application as an administrator. This is definitely not a great solution. It's more of a workaround, because you don't want your users to, have to run the application as an administrator. Lots of them don't have administrator access to their computer, and that also raises some security concerns. The second one is to have our installation wizard builder application that we're going to use towards the end of this course write those files or create those files for us, and then let our application use those files later on. But what happens if installer for some reason doesn't create those files, or if your user moves your program to a different folder but forgets to move those files, the program will just crash or it won't work properly. The third way to go about it, and this is the way that we're going to use in this video, is not to actually save to the program files at all. Now, Microsoft was kind enough to us developers to provide us with a directory in which the developers or the applications are supposed to save their files, any files that they need to. And this directory is writable to our applications. And you may have heard of this directory before. You may have browsed in it in your Windows Explorer. It's the application data directory. So if I open the run dialog, I already have it typed here. And if you want to access it, you just type literally this, the %, app data, %, all capital, and then hit OK. And as you can see here, in my case, the Windows Explorer window opened. There's a lot of applications here. There's a lot of applications on my computer, and a lot of them have their folders right here. So if I open the Notepad++, you can see here that it has a lot of XML files and an ini file. And one of them is called config.xml, and I'm going to go ahead and guess that this is where Notepad++ saves its settings. A lot of other folders right here obviously will be different on your computer. FileZilla, all of this stuff, all of them XML. And notice this, q.sqlite3. So it's saving, FileZilla is saving some sort of a database to this app data folder. This is Microsoft recommended place to save files that your application needs. This folder is not deleted. It's not that temporary folder. It stays there forever. Here's the thing, however. If I click right here, you'll notice that the path to this folder is C, users, Bogdan, my name, app data, roaming. Now, obviously everyone's going to use a different username, and additionally, across different versions of Windows, we have a different path right here. Windows XP, for example, has C, documents and settings, and then username, and then I think this folder is actually called application data, then it has local and all the other stuff as well. So we need to find a way to actually access this path, this one right here, somehow without having to hard code it manually. Luckily, Python enables us to do that. And in order to do that, I'm going to import the OS module that comes with Python as a standard library. The OS module has to deal with the OS specific stuff, so operating specific stuff. Now I'm going to access a method from the OS module that will help me determine the path of the application data path. So let me do this. I'll say app data path is os.environ app data. Environ is short for environment, and for now think of it as if it refers to your operating system, and that's it. So you'll have os.environ app data, which returns the application data directory on your system. And if I open the Python interpreter right here, let me import OS right here and do os.environ app data, do a function call. And as you can see right here, it returns C users Bogdan application data roaming. So it returns that folder, that root folder that I showed you a minute ago. But here's the thing, you've noticed that that folder contains dozens of other subfolders, each that belongs to one application. So we'll need to create our own folder there, and that's very simple to do. We'll just do plus and then double backslash so that I escape the one, and this one, the folder name should be PyDataMan. Then I'll add another double backslash so that later on when I'm using this I don't have to add it before a file. Now, some of you Python gurus may be wondering why am I not using os.path.join. Well, .join does pretty much the same thing. It's still, I need a string right here, and I don't really want to introduce any new methods than I already have to. Okay, but what happens here if this, if the user has just installed our application, and by default this folder PyDataMan will not exist? Well, one way is to create again through the installer wizard, but like I said, that can fail. So it's better to have us create this folder if it doesn't exist. Now, a sort of problem here is that this will not raise an error if this doesn't exist. As far as Python is concerned, the app data path is a string, and the interpreter doesn't know what you're doing right here doesn't know that it's actually a path. It's not looking up this to see if it exists or anything. But let's make it look up this folder and see if it does exist. So I'll actually say if not os.path.exists, and this takes a string as an argument, which is appdataPath. Let's just create that. os.makeDirs, which is short for make directories, appdataPath. And there we go. Now let's go bug hunting before we even test our application. This can raise an exception. You probably wouldn't know this unless you've read through the OS documentation. This is just something I happen to know because it has happened to me. It very rarely happens. The only way it could happen is if this fails, and this rarely fails. But anyway, let's account for this possible exception raising. So I'll encapsulate this in a try and except block. And I'll say except exception, no comma, exception, comma, E. We'll use this E later on. I'll just say appdataPath is os.getCWD. And the getCWD method returns the current working directory. Let me open up the Python interpreter again, and if I type os.getCWD, you can see that my Python working directory is C Python 27, which is the default on a Windows machine. Speaking of a Windows machine, I'm honestly not sure what this method returns on a Linux machine. My guess is that it either returns nothing, or it likely returns the path to your home directory, which is where applications are supposed to store their directories on a Linux machine or on other Unix machines like Mac OS. What we're saying right here, however, that if there is an exception, there is a problem making this directory in this path right here created in the current working directory. Now, our current working directory will be the program files, but this is just a fallback that will happen in maybe 0.01% of cases. And if a user reports that his application is not saving settings, or that there are some other errors, we can just tell them to try running as an administrator. Okay, so we have done that. What do we do now? I'm going to import another module that we're going to use, and it's very useful, and it's called logging. The logging module allows us to log the output of our application. Well, not exactly the output. Think of logging as printing to a file. You know how sometimes the application in its directory has a log file that a developer would probably ask for you to send to them if there is some sort of problem with that application. Imagine this, for example, if you distribute your application and you have either handled or not handled an exception, and a user says, hey, you know what, your application is not working, it just says unhandled exception error. And that's all the user can tell you, because there's no other way for a user to know what's going on. Now you could, in theory, go code hunting and see what is going on with that, or you could log a bunch of different outputs to a file and then ask the user to send you the log, and you can see in the log file what exactly is going on. So that's what we're going to do. It's going to make our lives easier in the future. Now, to define logging, we need to pass a few parameters to its method called basic_config method. The first parameter we're going to pass is the file name that the log is going to be saved to, the log file. So I'll say file name equals appdataPath. Remember that every file that we save and use from now on in our application, unless otherwise specified, will be saved in the application data directory. And then here again I'll say plus, we'll not use the join method. Let's call it pydataman.log. Fairly simple. The next parameter that we need to pass, and since this is going to be a long string, I'm just going to put in the line here, is format parameter. And format parameter basically outlines what our log should look like. So if we just, for example, had a traceback of what happened if there was an unhandled exception in our application of what happened, that would still be useful, because the traceback in Python is, fairly fairly good. It gives you the line number and what happened and all the other stuff. But sometimes if we catch an exception, we also want to log that. And in that case, unless we've imported the traceback module and we use the sys.exception info method, we're likely not going to have anything other than the actual exception error shown here. So we'll change that. And we'll change that in a way that we want every log entry to our log file to contain a bunch of other information. Now this argument is passed as a string, and I have it on my clipboard, and I'm going to paste it right here so you don't have to watch me write it all out, but I will explain it. Okay, so this is a custom format for a logging module, and if you want to see what are all these things that you can pass, you'll need to look up the logging documentation. As for right now, I will explain them shortly. So this is basically, as it says, it's time, and it's time as in hour, and I think even not milliseconds, or yeah, milliseconds, but it's not in the Unix timestamp format. It's literally 2012 December 6th, I don't know, 1335 and 148 milliseconds. Name is something that we'll see what it is in just a second, so I'll skip that for now. Level name. There are, I think, 4 or 5 different levels in logging module. The info, debug, warning, and error, and I forgot the 5th one. But those 4 are like the main ones. Module. Now, this is something that is also very useful when figuring out where it came from. The basic config, the logging.basicconfig method is only going to be called once across all of our modules. So if I want to log right here, I'm not going to call the .basicconfig again. I'm just going to do something else that we'll see in a minute. But the module part says what module it came from. So did it come from main.py? Did it come from about, preferences, utilities, and all the other modules that we're going to define too? Func name is the function or method name that caused the log to be, logged. We're logging stuff manually, although we'll see how we can automate part of the process. So if I log an entry right here and add button click, this func name will be add button click. Line no, as it may be understood by now, is line number. And finally, a message is a custom parameter that we're going to pass every time that we log something. Okay, there's a lot of other parameters to pass, but I'm not going to use any of them right now. What I have to do, however, we have defined the basic configuration of our logging module, but we still haven't exactly established the logger yet. So I'll say logger equals logging.getLogger, and I'll say name equals main GUI. What does this mean? Well, this is that name. So even though we have the module right here, it's still useful to have this name, because you can use multiple names in one module if you wish. So we're not going to do that, but you can. So every time we actually want to log something, we'll call this variable or this object right here logger. We'll see how to do that in just a sec. So we've taken care of our logging module, and other than Qt core and regular expression module that we won't get to in this video, we still have SQLite 3 unused. Now, if you have not heard of the SQLite or don't know what it is, do look up online. It's very useful. It's a database engine, and you may have heard of MySQL or Microsoft Access or Oracle database, PostgreSQL, and all the other stuff. SQL stands for Structured Query Language, and some people prefer to call it SQL. I prefer SQL. Doesn't make any difference. The difference, however, is that SQLite is very lightweight, yet very powerful. And also MySQL, I believe, not 100% sure about this, requires a MySQL server to be running in the background if you want to perform any database operations. SQLite, however, only requires a file to write to. And a database is basically a table, nothing more, nothing less. A table with certain columns that we're going to define and rows that we're going to add as we go in the code, and we can have multiple tables in one database. But my point here is that SQLite saves to a file, and not to some server stuff, so just a regular file. And speaking of that file, let's create it right now. So I'm going to place an object outside of my constructor class, but inside of my class in itself, and I'll call it dbPath first. It'll be a variable string. And remember, we need the app data path as the first parameter, or the first part of the string. And the second, we'll just call this pydata.db. Doesn't really make any difference. So notice that we're saving our database to our application data folder as well. Now what I'm going to do is create another object that I'm going to call dbcon for db connection. And this is going to be SQLite3.connect dbPath as an argument. So now we're telling the SQLite3 module to connect to this path and treat it as a database path. Okay, so we have finished doing this right here. But we have connected, however, we have not added any stuff to our database. It's currently an empty file. You know what? I'm not sure if this actually creates a file or if it does nothing yet. What happens when our user opens our application right now, and suppose that here we have some sort of add to this database method, function, or whatever call. If we try to do that, it will raise an error because we haven't defined any tables in our database. Think of table as literally a table. So our application has that one main table, and we're going to have one table in our database that will sort of be a mirror image of that main table in our application. Of course, you don't have to have a table in your application in order to save stuff to a database, but in this example, we do. First thing, however, that we need to do is create that table in our database. So to do that, I'll do this. I will need to create first an instance variable of a cursor object, and I'll call that dbCursor. And that'll be self.dbcon.cursor. The cursor object allows us to manipulate the database in that we can execute certain queries, and remember SQL stands for Structured Query Language. And let's actually execute a query right now. And notice that this is in the constructor method of our class. So it will be executed the moment our application is created, since this is our main application right here, main application class. So I'm going to call a method of the dbCursor object that says execute. And the execute takes a string as an argument. Now, if you don't know SQL or SQL, which is a language in its own, don't worry about it. It's very simple. It's basically kind of like weird English without grammar. So I'm, however, going to put 3 quotes right here on each side because it's probably going to be a long line. So just to make sure, the first query that we're going to have is create table if not exists. What's this telling our database right here, our file, is to create a table if it does not exist. If we call the create table only, that's still a valid SQL statement. However, it will always create a table, and if that table already exists, it's going to raise an error. Now the next thing we need to do is name our table, and let's just name our table, in this case, main. Okay, so this table, like I said, consider it a standard table. It needs columns, right? Just like our table in our application needed columns, this table needs columns as well. So let's define those columns. I'm going to open a parenthesis right here, and then I'm going to say ID integer primary key. Okay, now you're confused probably, because we don't have this ID in our in our main table on our application. And what the hell does primary key mean? Obviously you're confused only if you don't know SQL. If you do, stop listening to me for a couple of seconds or so. But anyway, ID will be the first column in our database table, and it is going to be a unique number, and it's going to be a primary number in that it's sort of like the most important thing, and it's going to be a key. And look up online what exactly the definition of a key in an SQL is, but my understanding is that a key is basically, again, a unique number by which you can search for any other element in the row. So later on, when we select a row, when we want to find the row in our column, we're going to say search by ID. For example, we may not, your table could be created without this as well, but it is a good idea always to have an ID in the table that is unique. Notice here, however, how we're saying integer. And the integer, you know what it is, but in Python it's not defined as integer, it's defined as int. SQL doesn't take Python, or rather the syntax is not the same as Python, obviously, so it takes integer, and we'll see in a second what it does with string. Speaking of which, let's define a string, and I'm going to go to a second line right here. So our string would be the first column in our main table on our application, which is username, and the string type in SQL is text. That's it for this. The second column is name, or the first name, which is also text. Third column is phone number. The fourth one is address, also text, and finally status is text. And with this is, how we have defined the columns in our application right here. So this one may seem slightly confusing, but as you can see right here, we're separating by comma different columns, and we're just passing an argument that says text. You can obviously pass a lot more arguments right here and look up the SQLite documentation if you want to do so, but for now these will just do. The only drawback of SQLite is that it does not support a whole lot of types. There's text, there's integer, there's a few other things, but there's no advanced stuff like Boolean, for example. Boolean would be very useful to have, but it doesn't exist, as far as I know, in SQLite, at least in the Python module. Okay. With this, however, even though this method may, by its name, say otherwise, we have not actually written any of the data to our table, to our file right here. So we have executed this query, but we have not committed it. We have not saved it to this file. Now, in theory or in practice, we can execute multiple queries in a row. Right now, I could say, self.dbcursor.execute, and then add some elements to this table if I wanted on a second line of code. Even though we don't want to do that, we want to actually commit to our database right now. So how do we commit? Very simple. I'll just connect or call the dbcon object, which is our connection object, and call its commit method. And with this command, any changes that we had queued with the execute is now actually committed or saved to our database. Okay, so we have committed our changes to our database right now. What are some other things that we can do to make our application more awesome and to make our lives a lot easier when dealing with the rest of the application later on? Well, how about for us to find a way to deal with settings? Now, when the user opens the preferences dialog and checks whatever settings we're going to have there, the user obviously wants those settings to be preserved after the application has shut down and restarted itself. Obviously, it's probably crossing your mind right now that we need to save those settings to a hard drive, and you're right, we need to save to a file. Well, in our case, to a file. Remember how I said earlier that we need, when I was talking about the application data, that we need it for two files for now, and one is the database file that we have already defined and dealt with, and the other one was the settings file. The settings file, I was ambiguous when I said it on purpose. There are a few ways to set and retrieve settings from and into a file. One of them would be to use the Python standard cpickle module. The cpickle module allows you to write Python objects to a file and later on retrieve them as Python objects as well. So we could potentially have a dictionary type in which keys will be, the name of the setting, and the value will be whatever the user has set. And that's fine, but it's not preferable for a GUI application. Another way would be to actually create another table in our database right here. And then we can, add a table that has only two rows, in which the first row would be again the settings name, the key, and the second row will be the value of that setting. But that's not really preferable either, because we may want to provide a button in our application that will clear the database, start from afresh, and that'll mean we clear all the settings as well. Plus, that can be unreliable somewhat. So how do we save settings to a file? We'll meet the QSettings class, and the QSettings class is an amazing feature of Qt as well. It basically allows you to, it's cross-platform obviously as everything else in Qt, and it allows you to store application settings either to a file or to some other native format. Let's write some code and see what it looks like. So I'm going to create an instance variable that says self.settings, and I'm going to assign it an object called QSettings. And there are a lot of parameters that we can pass here, and for now we're going to focus on 4. The first parameter that we can pass is the format that we want the settings to be saved to. Now we have an option of choosing between two formats. The first format is native format, and we can access it by saying qsettings.native format. It's a static method of the qsettings class. And on Windows, this will save to a registry. On macOS, it will save to that. I don't know what the name of their API is for that. And on Linux, it will save to a .conf file. The other option, and the one that we're going to use in our application, is qsettings.ini format. And you have probably seen a lot of ini files. I prefer ini. There's no real reason why, being as that native format is generally preferred. But I don't know, I just prefer ini. It allows for more fiddling and all the other stuff. And this will basically on all platforms write a .ini file that will contain your settings. Okay, the second parameter we want to pass is the scope. And what I mean by scope is that do we want this to be a system-wide setting for this application or a user scope, and that every user will have its own settings on whatever platform they're using. So on Windows, you can have multiple users, as well as on Mac or Linux machines as well. I'm going to use the user scope, which is also a static method of the QSettings class. So in this case, in our application, the settings will be tied to a username on a platform. Third, we want to pass the organization name of our application. The organization name is basically the name of the company behind your application. For now, we'll just say PyDataMan. It doesn't really make a whole lot of difference. And the fourth parameter we're going to use is the name of our application, which is also PyDataMan in this case. Now we can pass two more arguments to this constructor method right here, and one of them is parent, which we won't deal with, and the other one is also file name that we want to save to. File name that we want to save to is not exactly a safe argument, because a lot of times apparently it fails. Even the Qt documentation warns about it, to not specify unless you really have to. By default, QSettings will use that application data directory with the organization name as the folder, and since in this case it's the same as above, it will write to that directory as well. Okay, I'm not going to be calling any of the methods of the QSettings class right now. We're going to use that in the following videos, but let me just tell you, it's very simple and very useful. There are some drawbacks, but nevertheless much better than saving to a database or to using cpickle. Another and the last thing I promise that we can do in setting up the advanced skeletal structure of our code is scroll down to our infamous 4 lines of code that we have used everywhere, and we're going to do some modifications here. First thing I want to do is put all these in a main function right here, which I should define. There we go. And then down below, I'll just say if name is equal to main, execute the main function. And you have probably seen this 1,000 times. Basically, it protects us from executing the entire application if our code is imported as a module, which is not very likely, but still. Okay, one more thing and we're done, I promise. The in order to make sort of our application more professional, tell the operating system what it has to deal with, we're going to call a couple of static methods of the QCore application class. So the first method I want to call is the set application name, and we'll basically set the name to PyDataMan. The second one is the set application version, which we'll just for now say 0.1. Third one is the set organization name, and we have also used PyDataMan for that as well. And final one is the set organization domain. And we'll just say pydataman.com. Don't need the HTTP here. It's just a domain, not a website. Why are we doing this? Well, like I said, basically we're telling the operating system, okay, you're dealing with this. I'm not sure how Windows exactly uses these features right here. I think, for example, in the add and remove programs. Also, macOS prefers the domain. That's where it's going to save its configuration files to the PyDataMan, and it's just a good thing to have. Also, QSettings doesn't exactly depend on this, since we have also defined our organization and our application name in the QSettings constructor, but it likes to have those, so to say. Okay, I promise I'm done now. Thank you guys for watching this video and having the patience to go over how many minutes of it. As you can see, it's things are starting to become slightly more complex now, and they're only going to be even more complex. So give me some feedback, tell me what's going on, what it looks like, and all the other cool stuff. Thanks again for watching, and take care.